Hello, I am Michael Wilson, and I will be presenting my final project for Introduction to Data Science 1501. So my problem statement is about a data set for railroad crossing crashes in the United States from 1975 to 2021. This was a huge data set. It had over 100 columns and about 240,000 rows. So that is, and the three things I wanted to focus on in this are how the number of railroad crossing incidents has changed over time. Two, asking, is there any statistically important or interesting difference in the ages of the drivers? And three, is there any statistically important difference in the gender of the drivers? So walking through the code, I imported the data. Because it's such a large data set, it threw me this error, which I'd never seen before. And it took actually quite some time for it to load because it's quite a heavy file. But everything worked. I printed to verify that the information was there and working. So then I needed information about the years. So I created an incident year, and it is row 1 through 239,488, and it was column C, so I used 2 because we start with 0. And then I printed just to confirm that the information would display properly. So then then I generated a histogram of railroad crossing incidents by year. Um, so starting in 1975 and going to 2021. This graph skews right, and it shows that railroad crossing accidents have dropped significantly since the data started to be collected in 1977 or 1975. Correct that. The number of incidents plateaued around 2008 and has remained steadily in the 2000s number per year since then, with slight fluctuations, but yeah, like 1900 to maybe 2100 yearly, quite a few still. It would be interesting to see if we could drop those numbers lower and to understand what was happening at this time with safety or regulations that lowered those numbers. So now we're going to look at the driver age. This was difficult, wasn't difficult, but I learned that when you have a large CSV file on Excel, uh, it goes alphabetically A through Z, and then it does A through AZ, and then A through Z, etc. So I just had to add, this one I believe was CCB, so I had to multiply 26 by 4 and add 2 to get this number. Once again, printing to verify that the data was there. And then I wanted to have the data described with the total count, the mean, the standard deviation. And what I found was that the Q1 is 27 years old, meaning 25 drivers involved in accidents are 27 years old or younger. The median was 39, so 50% of the drivers were 39 years old or younger. Our Q3 was 53, and that means 25% of the drivers involved were 54 years or older. Um, From this information, we can say the majority of the drivers involved were between the ages of 27 and 53. And of course, with the caveat that this information only applies to the subset of the drivers involved in railroad crossing accidents and may not represent the age distribution of all drivers. And you can see here that the total count is 53,000, and we had 240,000 rows in our data set. So information about age of the incidents varied by the location where the incidents took place, whether the police department recorded that information or not. Starting in, I think, 1999, but in the late 90s, that became standardized, and they have data for age and gender. Um, Here's our histogram of age distribution for drivers involved in accidents. You can see there's some interesting outliers, like around 2021, highest at 21 years of age. Perhaps that could correlate to the legal drinking age in the United States. I can't prove that from this, but that's a theory. And then at like 30, there's spikes. There's like spikes around 40, a big drop off around 50, and then it skews right and quickly drops off around 65 years of age. Then I looked at gender values here. So we had about 60,000 with gender. We had more with gender information than age information. And it shows us here that about 75.4% of the drivers were male and only about 25% were female, which is interesting. Um, I can't draw any conclusions about that either, but it seems to indicate that there's a much higher incidence with male drivers. And here it is with a bar chart and the same information presented here using a pie chart. Uh, Professor, thank you for offering this class. I gained a lot of information about programming and Python uh, and how I can present data using it. Yeah, thank you for this basic, for this class in fundamentals. I found it to be very useful. Farewell.